All right. Hey guys. So in this assignment, what we're going to do is we're going to complete our build of our laser system. So just to give you a quick recap, we have in our game, we have our ship moving around and we have enemies coming down the screen off the top. Now, some key concepts that we're studying here that enable us to do this are arrays and loops. So the fact that we have enemies spawning every now and then at the top of the screen and scrolling down is enabled by the fact that we are creating a new enemy instance using our object-oriented techniques of defining a class or a blueprint for which describes an enemy. And then we're storing each one of those enemies inside of a list that we call an array. So if we pop over to our code here, we can see that we have at the beginning of our program a initialization of an empty array called enemies. And that's really step one. And we go ahead and we're going to use that to spawn enemies and store those enemies in that list. So down in our draw function, we have this little conditional statement here that's basically saying, hey, every 100 frames, spawn a new enemy. So what this line of code on line 25 does for us is it pushes or adds a new enemy to the end of the enemies list. So this list is an ever-growing list of enemies every 100 frames. Then immediately after creating a new enemy, if we're on the 100th frame, we loop through every single enemy and we index the enemy in the list by this variable I. This way, we now have the capability to control every enemy in the system. And right now, by control, we mean update and draw, because those are the only two methods that we've developed in the enemy. So if you wanted to extend the enemy to do other things, like maybe be attracted to our player character, or maybe do some animation, you would do that within either one of these methods, or create a new method that you can then call in this loop. But that's not what we're focused on in this assignment. It's going to be the same exact idea, that same exact workflow or design pattern for what we're doing with our lasers. So what we did yesterday is we defined this idea of a laser. And a laser, just like the enemy, has three methods associated with it. The first is our constructor, and that is responsible for initializing any internal properties of a single laser. And what we did here was we allowed us to input two parameters, x and y. And by doing that, we can initialize the x position and y position to whatever we input at the time of creation of a new laser. Now this is super powerful, and it's required because we need to be able to spawn a laser at whatever point the ship is at, right? Because the idea is we're going to be flying our ship around, and when we hit the space key, we're going to see a laser come out of the tip of the ship wherever we are. So let's see how we can accomplish this. Now the laser does two things, just like the other classes that we've developed. It updates and draws. In this case, the update is just decrementing the Y position, which will make it go up the screen. And the draw is just making a simple 10 pixel line that is drawn across the Y axis, so up and down. Awesome. So now where we left off was in our draw function up here at the top, we are detecting whether or not the user is pressing the space key, which is identified by key code 32, and then we're calling this ship.fire method. So remember, I just mentioned that if you wanted to extend things, you could just create new methods in these classes. That's exactly what we did with this ship. We created this fire method. So every time we hit space, we're going to go ahead and fire a new laser. So let's go down to our ship and let's take a look at that fire method. Now this fire method does something super simple. The same thing we were doing every 100 frames, we're now doing it only when this method is called, but we're using the lasers array or list. So we're saying this.lasers.push new laser And we're giving the new laser the ship's X position and Y position. Awesome. So at this point, we now have the capability to hit the spacebar and build an ever-growing list of laser instances that start their life at the position of the ship. But visually, this doesn't do anything for us, right? We're not there yet. The user can't actually see this. I'm hitting the space key and nothing's happening. So how do we rectify this? And this is really the core of this assignment. We need to be able to actually now loop over all the lasers in the system, just like we did with our enemies, and then draw every single laser in the system. So awesome. Where can we do that? Now, naturally, we'd want to think about this kind of in a physical way. The ship itself is the one doing the firing. So the ship itself should also be responsible for drawing its own lasers. This way that we could have multiple instances of different ships that are all independently shooting lasers. So what does that tell us? That basically tells us that in the draw method of the ship is where we can actually draw the lasers that we've initialized in our constructor. So the task here is really in the draw method, we need to loop over every laser and update and draw them. And once we do this, we should see the lasers scrolling across the screen. So how are we going to do this? It's going to be exactly the same as this loop up here, just using lasers instead of enemies. And we're going to be doing it in the draw method of the ship. So all we have to do is we're going to write a little for loop here. We're going to use I, and we're going to say we're going to loop for as long as I is less than this dot lasers dot length. Right, because we only want to loop as long as the length of the lasers list or the array. And we're going to go ahead and increment one at a time because we want to be able to touch or execute, update, and draw on every single laser in our system. So let's go ahead and open and close our curlies for that loop. Now the only thing we need to do here is we're going to say this dot lasers sub I, right? Because we want to touch every single laser dot update, and then this dot lasers sub I dot draw. Now, if we go to our game here and we fly around and we hit the space bar, boom, we're seeing lasers. But look what's happening. The lasers are drawing a little bit offset, right? And we're seeing a stroke the second we hit the laser around everything that's drawn to the screen. So there's a couple of problems here. We're seeing lasers, it's working, but they're not positioned right. So let's see what we can do about that. So the first thing we can solve is we have two problems. We have the border and we have the laser position. Let's solve the easy one first, which is the border. So having a stroke or a border on any of these things, the enemy or the ship, is easily solved by just resetting it every time we do a draw. So one thing we can do is we can go here, and every time we draw a enemy, we can say no stroke. And I'm just doing this right within the draw method of each one of the classes that we've developed, right where we do the fill. So we can put no stroke here, and then on the actual ship, we can also put a no stroke here. Now watch your case here, because it is capital S here for no stroke. Now if we go back to our code here, and we hit fire, we shouldn't see everything else get a red stroke. Okay, awesome. So now we have to solve for this laser positioning. We really want the laser to come out of the center. Now we could do it like this and maybe have two lasers, maybe on each side. That kind of would be cool. If you want to try to tackle that, more power to you. But what I'm going to do is I'm going to make this fire from the center of the ship. So we're going to have one laser stream. Now think about this for a second. What can we do to do that? Why does this happen this way? Now, if you recall, there is a local coordinate system for anything that we draw, right? And the 0, 0 point is in the upper left-hand corner. So what we're doing when we draw a laser is we're drawing the laser at the this.x position. So if we go down to the draw method of the laser, we're drawing it at the first point is this.x pos and this.y pos, which is going to be the origin point of the position of the local position of the ship at the time of rendering. So, and then we're moving up this.x pos and we're just moving it down by 10, which is why it's kind of in that left-hand lower corner instead of the upper corner. So what can we do to solve this? The x position is the horizontal plane, right? Not the vertical plane. So we want to move this bad boy over a little bit so that it's in the center of the ship. Now, we need to know the size of the ship for this. So keep this in mind when we actually put an image in here, because you will have to adjust this. So if we go up to the ship, you can see that we are drawing a triangle and we're moving the second point by 28, 56, and we're going up 45. So let's play with some numbers and let's see what happens. I'm going to go ahead and move this down in the laser. I'm going to move this x position by, say, 25. Just going to move it over by 25 when it starts. And now let's run it. And whoa. Now, 1 point, the first point is in the center, but the second point is not. So how do we solve for that? Let's go back here. Now, all we have to do is add the same 25 to this x position. So the second point is also moved over by 25. And now we should see the lasers somewhat coming out of the center. I think we need to make it 28 because that's what we did above, right? So 2 more pixels, 3 more pixels there. And now we should be in the center of our ship. Awesome. Now, we're still kind of down a little bit here, like it's coming out of the ship, which may be okay, but I'd really like to make it so that it comes out of the front of the ship. So now all we're really doing is adjusting the positioning here. So instead of minus 10, I'm going to try plus 10, and that didn't do it for us. So we do want to do minus 10. And we're in the laser, we're plus 28. So starting this down here. Okay, after a little bit of playing with some numbers here, it looks like these numbers work. And we're basically what we're doing is, and I encourage you to just play with this. There's no hard rule here. We're just playing with numbers. But we change the positioning of the X and Y position of the laser. So I'm inside of the laser class, and we just went ahead and just modified the positioning so that the start of the laser appears to come out of the front of the ship every single time. Now you can play with these numbers. If you change like this 80 to something like, say we changed it to 60, you'll see that the laser is going to be more of it's going to be smaller, right? It's going to be like this little tiny, or you can hold it and it'll just continuously laser out. But if you made it the same as this offset here, we should see the laser be more of a dot. So you may like this effect too, where it's this kind of dot. And you can play around with this, right? We can play around with the stroke weight, right? I think stroke weight is a function here. We can make it something like 5. Make it bigger, right? So play around with it. You can also change the color if you wanted to make it green, right? We could go ahead and make it green. But awesome. So this is basically the task. Really, the core concept here is populating an array with an instance of a class and then using a loop to loop over every single instance in that array and calling the methods on it so that we can actually use the features that we've developed. And now the powerful piece is we know in our system, we have 2 tables now that keep track of all of the enemies and all of the lasers in the system. And we're going to use this next week when we do collision detection against the enemy. So now we want to take it to the next step, and we're going to loop over every enemy or laser in the system. And then for every enemy, check the lasers to see, hey, am I being hit by a laser or not? And if I am, I should do something. All right, so awesome. I'm looking forward to next week. Please give this a shot. Any issues, please send me a message and let me know. All right, thanks.